Now you are in the duodenum. Notice that it's not covered with villi, because absorption is not the main objective of the duodenum. Mixing is the main objective of the duodenum. Remember, we added chyme from the stomach, pancreatic juices, 2 kinds, and bile. So I basically got 4 different fluids that are all converging in the duodenum, and I need to get them mixed together so that I can start all those chemical processes, so when I reach the jejunum, I can start absorbing things out of there. So notice the circular pattern of these folds. It's almost like threads on a screw or threads on a nut. So that anything that I put in this tube is going to tumble over and over and over and over and over as it goes through the tube. And just combine that with some peristaltic contractions, and you can see I can actually have a pretty significant mixing action in this first 10 or 12 inches of the intestine. Take a guess.
Esophagus and swallowing.
Okay, that sure does resemble what we were looking at earlier, doesn't it?
No.
But it's a little bit more than just that. You've got 4 of these.
This is sphincter.
Sphincter. This is one of your sphincters. Okay? My guess is that it's probably the pyloric sphincter. They have probably used an endoscope and they have gone into the stomach, and they are looking at the exiting hole, basically, from the end of the stomach, and it's in its contracted state at the moment. But any sphincter would look basically like that. We don't have enough surrounding clues to tell us where we are. Stomach. You're looking at what? Rugae. Okay. You've got a snapshot of the stomach here. You're seeing rugae in the stomach. Okay? And then this would be, and right about here would be pyloric sphincter, and then this would be duodenum, and then we kind of lose track, but we're somewhere in the jejunum. And that's as far as they went with the dye taking these pictures right here. What's happening on the stomach? No. Does that look like the normal shape of a stomach?
No.
So what's happening?
It's bigger.
Peristalsis. These are the waves of contraction.
Oh.
See? This wave of contraction started up here. And it has moved down. And then here's a wave right behind it. And then here's the beginning of another wave behind this one. So those are the propulsive, see? Those are the propulsive waves of peristalsis that would propel contents out of your stomach through the pyloric sphincter if it's relaxed. If the sphincter's tight, these contractions won't move in. It'll just stay in your stomach until the sphincter relaxes and says, okay, now we're ready for more. Because he's getting feedback from the duodenum and the small intestine. And when the sphincter gets signals from the small intestine that, hey, we're done with what you gave us before, he says, okay, here comes some more. And then these contractions push through another teaspoon or 2, and then he tightens up and waits till you deal with that. And then he gets signals that says, okay, relax again. Oh, yeah.
So, do you think that's what we feel like when you're like really, really hungry and you can almost feel your stomach like cramping? Do you think it's like contracting, trying to find food to push along? Because I know it sounds crazy, but
honestly, I don't know. I don't think that's the case, because typically the contractions are stimulated by the presence of food.
okay.
In the absence of food, they're much less active than they are when food is actually present.
Okay.
So I would think that the answer is probably going to be no.